Welcome to everybody. We are in 3D Innovation Lab. It's a lab where additive manufacturing is going to support all the three aims of Humanitas: the hospital, the research center, and the university. We have, let's say, three different lines of production. We have a biological cell lab where we have bioprinting, where we print 3D cell culture and tissue engineering in order to support our research center. In this lab, we have also the mechanical characterization of biological tissue, and for us, this kind of measurement is fundamental for all our production. Then we have two lines of production, one for the clinical needs, so for the hospital, not only for the surgeon, but for all the health professionals that we have in the hospital. And then for the university, we have both the production for the phantom, for teaching, for our students. We have different kinds of students, medicine doctor, nursery, physiotherapy, but also biomedical engineer, doctor together, the medtech course. And we produce also a phantom for training, simple training or also advanced training for our surgeon, for our students. What we have the best characteristic for this kind of production is that we are able nowadays to produce the physiological phantom, but we have the possibility also to produce the pathology in the phantom, so they are able to make the real hands-on with pathology, something that with all the simulator or cadaver lab nowadays is not possible. This kind of technology comes in Humanitas not from some surgeon, some specific clinical need, but come in Humanitas for, let's say, a strategic pathway. Don't be afraid, the world is going like this very fast. In order to, let's say, follow this velocity, we have to be on top of technology. Disruptive technology needs that someone break this kind of disruption. We already make, we are an example, we are able to share this kind of know-how.
The choice on the material it depends a lot on the request of the surgeon, because if the surgeon wants to recreate the consistency or the texture of the organ, we use basically matrix material, so bone matrix, gel matrix, and tissue matrix. While if the primary objective of the print is to understand the interaction between the various organs, we usually use the Vero material, so it's more rigid materials. For the choice of the material, we have printed a lot of samples, so when the surgeon comes and delivers us his request, we present all the samples and they decide whether it's like to choose one of the presets we have or to create a new material by choosing like the texture, the consistency of the material, and then we print different samples based on the request of the surgeon, and when they touch it and understand the various materials, they choose the perfect one for them. There are a lot of advantages, of course, that overcome these limitations, such as the resolution and the speed of printing. So basically when we have to have very precise and fast models, we use this printer because it's the only one that allows this kind of products, and also it's very easy to use, so that's for sure an advantage of the technology. Once you have like a very clear picture of everything, it's very user-friendly, the software, and the machine is very easy to use. So for sure having the 3D printed parts before, like having an understanding of what they will see inside, is very important for them. So I think 3D printing offers this kind of support, but also the personalization of medicine. So having also the possibility to print surgical guides, for example, or also very detailing stuff. It's very important for them because each patient is different. So not everything will work on everyone. I think the most important project I worked on is the phantom of the eye in subretinal injections, and it's a very complex procedure because they have to insert a very thin needle in between the retina and the choroid, which is a very small space, and not even the pig eye will allow this kind of behavior. So we printed a lot of trials, obviously, before arriving to the final product, but it was important to have this kind of technology because it allows us not only to print every layer stay together, but also to recreate the interaction between the layers, which was a very important part of the model.